Hey, what's up folks? This is Keith and you're watching Barbara's Auto Help. Thank you so much for watching. In this video, I'd like to share with you some methods that I use to diagnose either a blown head gasket, cracked cylinder head, or warped cylinder head. Now, in an attempt to make this video as concise as possible and to go as smoothly as possible, I'm going to be throwing up warning information on the screen from time to time throughout the video. Feel free to hit the pause button and review that warning information. This can be a little bit of a dangerous job. Anything you do on an automobile as far as repairs can be dangerous and you need to be careful. Also, please read the entire description below this video or to the side of the video and review the warning information that may be found there. So proceed at your own risk. If you choose to do this, do it at your own risk. Okay, as always, working on a vehicle with a cat up underneath the hood is not a good idea. That's not safe for the cat. So be sure your cat's out of the way. I can't keep him out. So little history on this thing, and it is important to know the history of the vehicle whenever you're working on it. That can help you in your diagnostic process there. This is a 2004 Hyundai Elantra, and it has a leaking water pump, and the owner was driving it and it overheated, and they continued to drive it for a little bit there, and it just shut off on them. Well, it overheated, I think, a little bit too much there. I started it up the other day, and upon initial startup, it ran a little ragged. So I think I've got a blown head gasket. So we're going to go ahead and do some diagnostic work and determine exactly what's going on with this thing. So as with any diagnostic, it's always good to do a good visual inspection of the vehicle first. You know, you want to check your belts, your hoses. Your belts are good over here. We already know that the water pump is leaking. We've determined that earlier. And my belts and my hoses are good. We want to check our fluid levels. Our coolant level is low, of course, because the water pump is leaking. But you also want to check your oil level and check for intermixing with the oil there. Sometimes if a head gasket blows, it could leak into the engine, into the oil sump, and mix with the oil and create this slushy kind of milk chocolate looking substance. So you want to check that as well. Now, I've already checked that our oil level is good and there is no intermixing with the oil. It's also a great idea to scan the PCM to check for any diagnostic trouble codes. A lot of times, if a head gasket is blown, you may have misfire codes on particular cylinders because coolant is getting into the cylinders and fouling out the spark plug. So that gives you a better idea of what's going on. And the name of the game here is to narrow down precisely where the problem is. We're not just diagnosing a bad head gasket or a cracked head or whatever. We want to know where the problem is, what cylinder is being affected, and what exactly is going on before we actually tear into this thing, which we will have to do that eventually. So on this vehicle, I didn't have any diagnostic trouble codes as far as misfire codes. I did have some evap codes, which is totally non-related to any kind of mechanical fault that might be present with the engine there. So we're going to go ahead and move on. Now the first tool we're going to use is what's called a block tester. This is a tool that you can get at any part store really, and it's relatively inexpensive. I think this one might have cost 20 bucks, maybe less. And what it does is it tests for combustion gases inside the cooling system. And the way it does that is via this special fluid right here. This is a blue fluid, and whenever it comes into contact with combustion gases, it turns into a goldish yellow color. So you can see there, it's nice and blue. And we're going to go ahead and perform this block test. Now we're going to be testing for combustion gases in the radiator here. In order to do that, we have to remove the radiator cap. Now this vehicle has been sitting for a day and a half, not running. It's perfectly cool. There's no pressure on the cooling system right now. However, if you do open up your cooling system, make sure it's completely cool before you do so, and make sure there's no pressure on the cooling system. A lot of times you can just squeeze the radiator hose and see if it's nice and taut. If it's nice and taut or firm, there's a good chance there's pressure in the system, and you need to use extreme caution. Now, I'm going to open up this radiator cap here. I've got a couple of rags to put over it. However, you may want to use a thick, damp cloth, and that'll help to give you a little extra protection. Now, I've got it turned all the way counterclockwise, the radiator cap that is, and I'm going to use caution when taking this off. We don't want anything to spew out on us. And we're good to go. And you can see the coolant, there's no coolant at the top there, so obviously we got a leak, we got a problem. But use extreme caution when you do that, guys, okay? All right, we need to go ahead and crank the vehicle up. Alright, we got the vehicle started. You can see I've already got some, looks like steam or smoke coming out of there. It might be a little steam. It shouldn't be hot enough to create steam yet. So I believe that's combustion gas there. We're going to put our tool inside like that. Take this little bulb here. The check valve goes on the top. I'll sit it right in the middle of that like that. Alright, so now what I'm going to do is I'm going to rev the engine while I squeeze this bulb and suck gas up through the fluid. You can see it's already starting to change colors there. Not quite blue. So we know we're getting combustion gases into the cooling system. So we've probably got either a blown head gasket or a cracked head. There's a possibility there might be something else going on, like a cracked block. But we want to isolate it a little further, find out what particular cylinder is affected by this, and that will help us later on to feel more confident about where the problem exactly is and what's causing it and what the best course of action is going to be to repair this vehicle. So at this point, normally I would take either one of two different paths. One, I would take all the spark plugs out, pressurize the cooling system, or actually fill the cooling system first, then pressurize it and bore scope each cylinder to see if there's any coolant intrusion into the cylinders. And here's some pictures of a particular engine that I did a pressure test on and bore scoped the cylinders on. This one did have coolant intrusion into the cylinders, and you can see that it's coming right down the cylinder walls there. In this instance, what I'm going to do is I'm going to do a compression test on all 4 cylinders and see if I may have one cylinder that's below the other ones just a little bit there. And I chose this path mainly because of the severity of the water pump leak. The engine won't hold any water, so it would be useless to pressure test it because it can't hold pressure anyway. So I'm going to go ahead and take the engine cover off and take all the spark plugs out. Whoa, oh, I lost that one. That's what magnets are for. Alright, so I got the spark plugs out and I got them out in order. This is cylinder number 1 through 4 here. And it's not a bad idea to check your porcelain and just check the condition of the spark plugs. A lot of times the porcelain and the tips of the spark plugs can tell you a lot about what's going on inside the engine. In this case, they look just carbon fouled there. I don't see any evidence of coolant or anything like that, so not exactly what we're going for there, but never a bad idea just to look at your spark plugs to see what's going on. And of course that can give you an idea if you have one particular cylinder that's getting coolant into it, if you see that evidence. A lot of times if you have orange coolant or red coolant, it'll have kind of a orangish reddish tint on the porcelain of the spark plugs. If you got green coolant, it may be a little bit green. If you've got just plain water, well, you're out of luck. I think that's what we got going on right here. They just have pretty much plain water in the cooling system. It's rusty water actually. This one right here, there may be something going on with that, possibly, don't quote me on that, but a lot of times the water will wash the porcelain a bit and it looks a little cleaner than the others. Anyway, let's go ahead and hook up our compression gauge to it and see what we got. Okay, let's go ahead and start out with cylinder number 1. Alright, looks like we have 120 psi on that one, but what we're looking for is a difference between the cylinders. Ideally, you want to have all cylinders at the same compression. Let's check number 2. that cylinder is about at 105, so there's a difference there. I'm going to do that one more time, because sometimes if you don't spin the engine the same amount of revolutions, you could throw that off there. So never a bad idea to do a compression test twice on each cylinder, actually. So I'm going to do that one more time and see what I got. That one's still sitting there right at about 110-ish. So there's a difference there. Let's go ahead and move on to cylinder number 3. All right, let's see what we got. And that one's just above 120. Let's check out number 4. And that one is at 155, 160. So quite a difference between all 4 cylinders there. Number 1 and number 3 were the closest, but that's a big jump, 150. So I think we're jacked up inside there. Now, sometimes what can happen, and ultimately we're going to have to tear this thing down to point of failure. Sometimes what can happen, and it may have ingested some coolant into the cylinders on this one. I'm not sure. If it did, there's a possibility we might have bent a rod too. So not only do we have a blown head gasket or cracked head, we could have a bent rod as well. But let's keep on going. And I think I am going to go ahead and bore scope these cylinders just to see what's going on. I suspect I got something really major going on with number 2, and then something with number 1 and 3 as well. So I'm going to go ahead and hook this up to my cell phone and take a few pictures. So a few things I like to check whenever I bore scope a cylinder. Of course, the top of the piston is one. You want to make sure there's nothing damaged inside there, no puncture wounds or anything like that on the top of the piston. Make sure it's not cocked inside there. Make sure you got good spacing all the way around the piston between it and the cylinder wall. Also, I like to check the cylinder walls all the way around and up and down. I want to make sure that there's a good crosshatch pattern on the cylinder walls and that there's no major scoring or any major loss of the crosshatch pattern anywhere on the cylinder wall there. And then, of course, at the top of the cylinder there, where the head meets it, you can see you have your head gasket, and I like to look at it all the way around. Sometimes you'll catch a little bit of water dripping from the head gasket area into the cylinder. And, of course, if you got a 90-degree camera, not only can you check your head gasket, but you can also check the valves, your intake and your exhaust valves. Make sure that they're not bent or damaged in any way. Of course, it's never a bad idea to bore scope the cylinders. I wanted to see if I seen anything obvious in there. Also, it's not a bad idea to check the conditions of your cylinder walls before you go into the lengthy process of tearing down to point of failure. If you got major scoring on your cylinder walls, well, it's time for a used engine or a new engine, in my opinion. So just save your time. Just go ahead and get you an engine and drop it in there. And another good point to make here, we did check our oil level earlier, but it's not a bad idea to take an oil sample and get you a good bit of oil in the bottom of like a mason jar or something. Take a flashlight to it and check for shards of metal and shavings and things like that. If you got like some major glitter in the oil, like major glitter, it's time for a new engine. So just save your time. Don't go through all this. Put one of those in it. Now, another tool that can help you along in your diagnostic process is a smoke machine. You don't have to have one of these to diagnose this, but it makes it pretty plain as day as to what's going on and where exactly your problem is. If it works for your situation, not every situation where your head gasket's leaking will a smoke machine assist you. This one's leaking pretty bad. I tried it earlier and actually smoke was coming out of one of the other cylinders there. So what you got to do though is you got to get whatever cylinder you're checking at top dead center on the compression stroke. Once that's achieved, go ahead and hook up a line to the cylinder there. This is just part of the compression gauge that I used earlier. I took the check valve out of it though, or the Schrader valve out, so that air can go in. And then once your line is hooked up, you just take the end of your hose of your smoke machine and you hook it up to the line that you hooked up to the cylinder and just turn your smoke machine on. And what's going on is smoke is going into the cylinder. The valves are shut, right? So there shouldn't be any way for smoke to get out into the intake system or the exhaust system unless you have a bent valve or a leaking valve That does happen, but there shouldn't be any way for smoke to get into any other cylinder besides through the head gasket, or if there's a crack in the cylinder wall, which that's pretty far-fetched, but it does happen. So that is something you need to look out for there. But you can see already I've got smoke coming out of the number 1 spark plug tube. So smoke is getting into that cylinder some way. What I'm going to do now is I'm going to hook up my bore scope, and I'm going to bore scope that cylinder and look around the valves, make sure the smoke's not coming through one of the valves there, or possibly a crack in the cylinder wall. Albeit I did bore scope the cylinder earlier. I didn't see any cracks in it. I'm thinking that this is going to be coming from the head gasket, so let's go ahead and take a look at that and see what we got. So this kind of makes it plain as day. You can see here I'm bore scoping cylinder number 1, and I'm looking at the part of the head gasket that mates up to cylinder number 2 there. That's right in between cylinder number 1 and cylinder number 2. And you can see just right away, you see bubbles coming through the gasket right there, and you see the smoke coming through right there. So there's no question that that head gasket is leaking, whether it's just a blown gasket or a warped head, we don't know yet. Now, I did go ahead and take the liberty of bore scoping cylinder number 3 also, and you can see that there's no smoke coming through right there. However, when we did our compression test, both cylinder number 1 and 3 were 120 psi, and then number 2 was right at 105, 110 psi, and then cylinder number 4 was 150. So I'm thinking that even though the smoke didn't come through to cylinder number 3, I'm thinking that cylinder number 3 is bleeding over to cylinder number 2 and vice versa. Not every instance will a smoke machine assist you whenever you got a leaking head gasket. It's a very rare occurrence that a smoke machine can actually help you with this, but it's really cool when it does. So I just wanted to show you that too. Now, and yet another tool that is useful in helping in your diagnostic is a cylinder leakage tester kit, and this one's made by OTC. I bought this with my own money. OTC is not a sponsor of Barbers Auto Help, and as of yet I'm not affiliated with them, so I'm just, for the purposes of making this video and helping you out, I'm going to show you on this particular tool here. So you got this funky setup right here, and this is already a part of the kit here. You get a hose with it, and it does not have a check valve in it, so air can go in and out. You're going to hook one side up to the cylinder, and the other side we're going to hook up to shop air. Okay, so we have shop air hooked up to our gauge, and what we're going to do is we're going to turn this gauge up to 100 psi. I just like to put it at 100 psi because we're going to be working in percentages here, and that's a nice round number for me. So I'm going to crank it all the way up. So 100 psi is going to be going into the cylinder, and I think you can hear that air rushing. That's it, it's leaking basically is what's going on. So that's 100 psi. And the cylinder is actually only holding about 26, 27 psi. So right there we got about 75% cylinder leakage. Now, where's it going? Of course, we know it's coming from the head gasket. We've already determined that. But if you don't know that your head gasket is leaking, there's a couple of things you want to check. You want to check, of course, for air coming out of one of your spark plug tubes. You want to remove all your spark plugs before you do something like this, or at least the spark plugs from the cylinders next to the cylinder you're testing. And you do also want to have that cylinder at TDC, whatever cylinder you're testing, you want it at top dead center of the compression stroke. That way you know everything is closed up like it's supposed to be. So a couple things you can look for. In our case here, we got air rushing out of the cylinder number 1 spark plug tube. Because this one is leaking so badly, I'm not really able to hear anything coming out of number 3. I suspect number 3 is leaking too from the number 2 cylinder into number 3. But not all the time will you have a leakage like that. You may have a leaking exhaust valve or a leaking intake valve. Say if your exhaust valve is leaking, you'll probably hear some air rushing from the tailpipe of the vehicle, and also sometimes air can rush into the exhaust system and then back into another cylinder whose exhaust valve is opened up when it's supposed to be. I just killed my circuit breaker, guys. Anyway, what I was saying was, so you may misdiagnose it as a head gasket, because the cylinder that's next to it, the exhaust valve, may be opened up and air is rushing into the exhaust system and then back into that cylinder through its open exhaust valve. So you gotta use your common sense with this and know what's going on inside the engine to determine where your problem's at there. But usually exhaust valves that are leaking you'll hear air in the exhaust rushing through the exhaust. An intake valve that's leaking, usually you'll hear air rushing into the intake system there. If you take your snorkel off over there where the air duct goes into the intake, you may hear some air rushing out right there. And also, if your head gasket is blown in a different way, say it's not leaking between the cylinders, this one's leaking between the cylinders and into the cooling system, you may see air bubbles coming out of your radiator. So if you got your cap off and you see air bubbles coming from the coolant in your radiator, then you know you got a blown head gasket there. So just a few tidbits there. That's not a really in-depth explanation on this particular tool and how to use it, but this is a great tool to use to help you further along in your diagnostic process. So I know some of you think that what I just did is kind of overkill, and yeah, it is to an extent. I wanted to show you a bunch of different tests to help you and give you more ammunition to work with when it comes to diagnosing your own vehicle or whatever vehicle you're working on there. It never hurts to do as many tests as possible, unless you're a flat rate technician, which I am. I understand. You want to get to the point and get it done. But, you know, there's nothing wrong with being thorough and taking your time and doing a good job and knowing what you're getting into. So I think we're armed with a lot of information now on this particular vehicle. I feel confident going ahead and tearing into this thing and tearing it down to the point of failure here. So we're going to go ahead and do that. Okay, so we got the head off, and you can see between cylinders number 1 and 2, got a little discoloration on that gasket right there. I believe that's where combustion gases were seeping over from cylinder to cylinder there. You can definitely see right up in that area right there between 1 and 2. Definitely burnt a little bit, especially right in there. Oh, don't drop it, Keith. Burnt pretty bad. So now, while this is a very crusty looking gasket, I wouldn't consider it to be blown. This is a multi-layered metal gasket, and they are pretty tough. Typically, in my experience, whenever you have a leaking head gasket and it's a multi-layered metal gasket, it's due to other factors. However, if your vehicle is equipped with a gasket made from a different material, there's a good chance you'll see some physical damage to it, and you may see where it's been blown out or damaged in some way. So now what we need to do, we need to check a few other things too. We need to check our deck surface for flatness, and we also need to check our cylinder head for flatness. And we also need to get our cylinder head pressure tested and make sure that there's not a crack in the cylinder head somewhere, something that we don't see there. Now, a few other things you may want to check while you're in here and you're doing a repair like this. You want to spin the crankshaft over a few times and get all your pistons to TDC, top dead center, and make sure that they all come out or come up the same distance. If you have one that's a little bit lower than the rest of them, you got a bent rod. And sometimes that happens whenever you got a cylinder head gasket leak. Coolant gets down into the combustion chamber, and as you know, liquid does not compress. So all that energy with the crankshaft spinning, something's going to give, and it's usually the connecting rod. So if you got a piston that's down just a little bit compared to the other ones, good bet you probably got a connecting rod that has been bent because of a hydrolock situation. So you want to check that too. I'll give you a little demonstration here. So I've got a ratchet with a socket on the crank bolt, the crankshaft bolt right there. What I'm going to do is I'm just going to spin it with my hand, and I'll put you up here, set you down, and we can watch those pistons come up and go down. You want to make sure that when you're checking to see how high up it comes, you want to make sure it's at the tippy top of its travel. And you'll know where that's at because you'll slowly rotate it and it'll start to go down. Once it starts to go down, go back a little bit. Get it all the way to the tippy top right there. And of course, it doesn't hurt to take a measuring tool and just check the depth from the deck surface to the top of the piston there, and just make sure that they're both the same, or all four of them actually are just the same. And this isn't actually the best tool to do that with. There are actually tools specifically made for this. This just happens to be something I got handy right now at the house. But you get the point. You want to make sure that they all come up exactly the same. It's probably fair to mention that whenever you're measuring this distance here, you want to make sure that your deck surface is perfectly clean. You also want to make sure that the tops of the pistons are perfectly cleaned off. This isn't the case right now, but I am going to clean it up really well and clean the top of those pistons up really well, and then make those measurements again. That dirt and grime and stuff can actually throw your measurements off, so having your surfaces cleaned properly will help you to be more accurate. Now, another thing too that you want to check is your crosshatch pattern in your cylinder walls, and that'll give you a good indication as to how healthy the engine actually is. And you can't see it very well on this one, but there is a pretty good crosshatch pattern. There is some mirrored parts down in the bottom there a little bit, but the amount of mileage that's on this particular engine, that's to be expected. Here we go. I got my light turned on here. Let's see if I can get you down in that cylinder a little bit better so that you can actually see that crosshatch pattern. Yeah, see those lines that kind of crisscross each other? You got that going all the way up and down. This one's a little bit more mirrored. You can see those up and down streaks there. So a little wear and tear on this one. Well, you want to check all of your cylinder bores. Make sure that they're okay. And if you got some heavy scoring, some gouging, it's time for a new engine. And of course, while you're in there, go ahead and check for cracking in the cylinder walls. And after you get your deck surface cleaned up really well, go ahead and check for cracking on the deck surface as well. If you got cracking in the cylinder walls or on the deck surface, probably best to go ahead and get a new engine. That's just my opinion. All right, so here's the underside of the cylinder head. That's cylinder number 1, 2, 3, and 4. Actually, that's the combustion chamber part of the head, but this is above number 1, 2, 3, and 4. You get the picture there. And it's actually pretty obvious where the compression or the combustion gases were leaking back and forth on those two cylinders there. I'm going to do a little leak test on the valves on number 3 cylinder here, and just make sure that the valves aren't leaking on it. I don't think that they are. I think we still have a little bit of leakage between those two cylinders there on 2 and 3. So I'll clean it up. We'll check our surfaces for flatness, and I'll leak test those valves, and we'll go from there. Okay, so I've got my cylinder head cleaned up pretty well. That's just a little staining that you see right there. But before you do your measurements, you need to make sure that your surface is perfectly clean, because having any kind of foreign material, rust, debris, or whatever can definitely throw your reading off. So you have to have it perfectly clean there. So we're going to be taking a few measurements, and what we're going to be doing is starting at the top here. We're going to measure right here, 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 and here. And we're going to make sure that the straight edge doesn't allow our feeler gauge to go through. I've got my feeler gauge is just a little bit above what the specification is for this vehicle, and if it goes through, we got a problem. So we're going to do that. Then we're going to move the straight edge to this portion right here. We're going to do the same thing, except it's going to be right here, 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 and here. Then we're going to move it down one more to the bottom, and we're going to do the same thing down here that we did at the top. Then what we're going to do is we're going to take and make 3 measurements right here, 2 measurements here, 3 measurements here, 2, 3, 2, 3, 2, and 3, and you get the point there. So let's go ahead and start up here. So we're going to take our feeler gauge, start right here. Make sure your flat edge is perfectly level, and press down a little bit, not real hard. So all right, that's going in a little bit there. That's going all the way in. That's pretty loose. Pretty loose also. Pretty loose also. So right off the bat, this thing is not flat. So we got a problem. The head is not flat. So that goes in really easy. Like I said, this feeler gauge is just a touch above what the maximum spec is for this cylinder head. It should not be going through there that easily. As a matter of fact, it shouldn't be going through there at all. right there. There it is too. So you get the picture. I don't think there's any reason I need to continue on with that little procedure there, because we know that it's not flat. So it looks like we have a warped cylinder head. Now that's not necessarily the end of the road for a cylinder head per se. A lot of times what you can do is you can take the cylinder head to a machine shop and have it resurfaced, and that way you get that surface nice and flat again. Now, there are two sides to this equation though. There's not only the surface of the cylinder head that has to be flat, but also the deck surface of the engine block has to be flat as well. So now what we need to do is we need to measure the flatness of the deck surface of the engine block. Now on the engine block here, it's just a little bit different, but it's basically the same thing. What we do is we place our flat edge or straight edge diagonally across the block like so, and we take measurements right here, 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 and here. And then I also place it diagonally on the block like that, and I take measurements here, 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 and here. And then I take it a step further. In the same places like on the cylinder head that we did earlier, I do the same thing here, except you can't really put a feeler gauge right up in those areas because there's a water passage right there. But there is a flat spot on the other side. You might be able to put your feeler gauge through there and make sure that's nice and flat. So I check it right there, there, and then down here. You know, and just an afterthought, you notice all this rust right here. This is actually a recording well after I originally recorded this video. You want to go on both sides of that dowel when you're making your measurements, and just like you want on both sides of that dowel over there, you want to go on both sides of the dowel on this side as well. And of course, guys, most of your engines, they have different specifications as to what's acceptable and what's not, so you really have to refer to your repair manual for that information as far as flatness of your deck surface, which this is your deck surface right here, and also your cylinder head mating surface. Refer to your repair manual for those specs and use some good quality feeler gauges. All right, so as mentioned earlier, I'm going to go ahead and check to make sure that my valves aren't leaking, and I'm going to start with the exhaust valves. And what we're going to do is just kind of sit the head over on its side like so, and I'm going to pour water into each of these exhaust ports here, and I'm just going to simply look for water leaking out of the valves there. Pretty simple process. And it looks like we got a leaking valve already, and that's on hey, that's on cylinder number 3. So I think that's where the compression was going that we were worried about earlier. Well, part of it anyway. I think some might have been going through the head gasket still, but yeah, looks like number 2 is leaking also. It looks like we got a bit on number 4 as well. Now let's do the same thing for our intake valves here. Just going to take and pour some water into the ports. That's cylinder number 1. It's leaking. I need to go get some more water. Cylinder number 2, or cylinder number 3 is leaking. Number 2 and number 1, oh, and number 4. So all of my valves are leaking. Okay, so at this point, I'm ready to give an official diagnosis, and that's a cylinder head gasket leak due to the fact that the cylinder head is warped. And the reason the cylinder head is warped, of course, is because the vehicle was overheated. It was actually overheated so badly that the engine actually shut down. And of course, it overheated because it didn't have any coolant in it due to the leaking water pump. Now, typically what I would do in a situation where I just have a warped cylinder head and a leaking head gasket, and I didn't have a bunch of extra problems, what I would do is take the cylinder head to a machine shop and have them perform a pressure test to it. A pressure test performed to the cylinder head will help to determine if there are any coolant leaks in the cylinder head itself. A lot of times if you have a crack in your cylinder head that you couldn't detect with your eyes, the machine shop can help you find that. And if the cylinder head passes the pressure test, I would have them resurface the cylinder head for me. That will ensure that the head gasket has a nice flat surface to mate against. And then, of course, I would reassemble the vehicle with a new head gasket and, of course, all the new one-time use parts. However, in this instance, I didn't go that route. In light of certain information, I determined that it was best not to repair this particular engine. One of the main deal breakers for me, and you didn't know this information, but previously the engine had been run without oil in it. This actually happened several months ago, and we were able to get some engine oil for the owner and top it off and send them back on their way, and they've been going pretty good ever since, other than the fact that their water pump sprung a leak. Another point of concern for me was the fact that it doesn't look like the vehicle had had routine maintenance performed to it. There was a lot of sludge inside the oil system, and all these brass and copper looking components inside the engine, they're not supposed to be that color. They're supposed to be shiny silver, and that's evidence that the oil hasn't been changed regularly. And also inside the cooling system, there's a lot of rust water inside there, and that rots the inside of the engine, the inside of the head, the backs of the freeze plugs. So that rust has been eating the inside of this engine for quite some time. Now, with that information aside, when I tore the engine down, I found, of course, metal in the oil. Also, the cylinder bores towards the bottom, they were a little bit polished, so good wear and tear there. The cam bearings had some damage to them as well. And of course, near about every valve on the cylinder head was leaking. Also, when I went to check the flatness of the deck surface on the engine block, it was barely in specification. It was in specification, but it was like just barely there. So that was a little concerning to me. That, coupled with all the other information I know about this engine, I thought it was best just to go ahead and put a used engine in this vehicle. Now, we didn't go that route either. In discussions with the owner of the vehicle, the conclusion was made that they just want to get a new vehicle. So I'm down with that. So I hope that this helps you in your understanding of how to diagnose either a blown head gasket, warped head, or cracked head. And I really hope that this video also sheds light on the importance of checking over all of the components that you come in contact with in the process of diagnosing a blown head gasket, cracked head, or warped head. You really do need to be well aware of what condition your engine is in overall before you complete a project like this. It's a lot of money. A head gasket set's pretty expensive. Also, you have to send the thing off to a machine shop and have them work it over. So you could be $500 to $1,000 deep in parts, and then 10-15 hours in labor, and then find out that you needed more than that. So that's a bad situation to be in. And folks, while I did go into checking some of the peripheral things in this video, other than a blown head gasket, cracked head, or warped head, that's not the main thrust of this video. I did, however, want to plant that seed that those things need to be checked as well, but this video is not a fully comprehensive video on checking those things. And of course, I didn't go over every single thing that you need to check while you're in there. I just went over some basic things for you, and mainly wanted to plant the seed that you need to be cognizant of these peripheral things, and to not just keep your blinders on and go straight after the head gasket. I don't want you to get in the pickle. You do need to do some more research before you go tearing into your engine. So folks, I sincerely hope that this video was a help to you. If you have any questions, please comment down below. Also, please read the entire description down below or to the side of the video, and please read the disclaimer at the very end of it before you apply any of this knowledge, okay? Thank you guys for watching. Please like and subscribe.